So our third type of reaction was single replacement reactions or single displacement reactions. I don't care which one, different books use different names. A couple of things to be aware of. The first thing you should do is write the formulas of the reactants, the symbols and formulas first. And then again, just to remind you, not every reaction you can write down on paper will actually take place. Either look at your book, if you have your book, page 333, or use the, oops, it's over here. Use the activity series to determine if that free element is higher than the one that's in the compound already. If it's able to knock it out. So let's try a couple of these and see how we go. If it can occur, you write out the equation, you write out the formula, you write the names, all that stuff. If it can't occur, put an X through the arrow and put no reaction. Okay, so let's try a couple of each of these and see how we do. So lead, of course, is Pb. It's solid at room temperature. Zinc and acetate, remember that crazy ion. Doesn't matter how you like to write it. C2H3O2 is how inorganic chemists like to write it. We're going to put this in parentheses because remember, zinc's a +2 always, acetate's a -1, so we need 2 of these. Okay, so lead and zinc acetate. So the next thing we have to figure out is who's stronger, who's higher on the activity series. And so we just kind of read down. Oh, there's zinc. Haven't seen lead. Oh, lead's way down here. Lead is a weak link. This reaction's not going to happen. So that's the kind of thing we'd like to have. I will tell you there are 2 more of these that won't react at least. Okay, all right, so there's one of the no reactions. The next one is, I'd like to try and do, let's see, I was going to do this one. I'm going to do number 3 because I forgot to write down the name. So the name, because nickel can have more than one charge, we're going to assume this is nickel 2 nitrate. So that should help you out a little bit. So silver nitrate, that's the stuff that we use in the little brown bottles. You'll see that in the lab next week. Ag is silver, NO3 is nitrate, +1, -1. And nickel is a metal at room temperature. It's a solid. So can nickel bump silver? So these are in reverse order, but you need to recognize that nickel's a metal and so is silver. So what we're looking for is, can nickel knock silver off of the nitrate? So we look, and remember the coinage metals, this is another hint to help you. Silver, platinum, gold, copper, they're all pretty non-reactive. They're at the bottom of the list. So here is nickel and here is silver. Yep, nickel is strong enough to bump the silver off. So if it's nickel 2 nitrate though, that means the nickel has a +2 charge. That means we're going to need 2 nitrates. I'm going to assume it's in solution, and then the silver is going to be out in the cold by itself. Okay. All right. So now we got to do some balancing to get this reaction all set. Since I got 2 nitrates on this side, I know I have to have at least 2 on the reactant side. That gives me 2 silvers and 1 nickel. 1 nickel. We're good. All done. All right. Let me do one more. Well, this one you already saw, so you don't have to do this one again. This is the sample that I gave you already on the graphic organizer. So let's see, which other one did I want to do? How about this one? I'll do one more with you guys. So magnesium, Mg, is a solid. And nitric acid, so you're gonna have to look up your acids. HNO3 is nitric acid. And so what we need to see is, can magnesium knock hydrogen off of nitrate? And again, magnesium's way up here, hydrogen's way down here. Yep, it can. So we're going to end up making magnesium nitrate. And hydrogen's going to be out in the cold. So magnesium's always a +2. Nitrate's always a -1. And you gotta remember, hydrogen's one of those diatomics, so be careful there. So the next question is, are we balanced? No, we're not. We've got 1 magnesium, 1 magnesium, 2 hydrogens, 1 hydrogen, 2 nitrates, 1 nitrate. Oh, this is easy. So we're gonna put a 2 here. And now we're balanced. Remember to be careful, only replace metals with other metals, or hydrogen, and non-metals with other non-metals, and watch out on those non-metals, and watch out for diatomic elements, okay? So be careful. Also, think about water as hydrogen and hydroxide stuck together, and they come apart that way. Take good care.